Hello students, welcome to Spectra Education Academy. In this video, I am going to discuss the definition and applications of impulse. First, let us try to have definition. When large force acts on a body for short intervals of time, a finite change in momentum, finite change in momentum, in linear momentum will be produced, is called impulse, or we can say impulsive force. Now, so from Newton's second law, so what we can write is F is equal to dP by dt. So dP is equal to, this is change in the momentum, F into dt. So therefore, impulse of a force, look at this equation, impulse of a force is the product of magnitude of force and time interval during which it acts, Okay, so from this, looking at this equation, we can also say that impulse is numerically equal to change in momentum. So you can say this is impulse. Impulse is numerically equal to change in momentum. Next, so this is one more point. This is the one point. Now, even you can elaborate the change in momentum as m of v minus u when mass is constant. So we can also write F into dt. So you can expect numerical based on this equation. Next, if force is variable, in the given time interval, so then we can write impulsive force as I is equal to dP, this is equal to F into dt. So time interval t1 and t2. So at t1 we can also write this as, so its momentum may be p1, its momentum may be p2. So therefore I is equal to, we can write that p2 minus p1, because integration of dp is just p. So p1 is the momentum at t1 seconds of time, p2 is the momentum at t2 seconds of time. So we can write dt. So therefore, so there is a process to substitute upper integral in place of p and lower integral in place of p. So therefore p2 minus p1, this can also be written as m of v minus u, because final momentum is mv, initial momentum is mu, is equal to F into dt. So t1 and t2. So equation may be given for F in terms of t. So then we go with integration, so you'll get the answer. So you can expect numerical even on this step. Now, so there is one more equation for impulsive force. If F1 is the force acts on a body for t1 seconds, F2 for t2 seconds, F3 for t3 seconds, so on. Then change in the momentum. Change in the momentum of the body is mv minus mu is equal to F1 T1 plus F2 T2 plus F3 T3. So there will also be numerical on this step. Next. So there is one more application. If F1 is the force, acts on a body at rest for t1 seconds. If F2 is the force, acts on the same body to bring it to rest. Then, so we can write F1 T1 is equal to F2 T2. So there will also be numerical on this step. Now there is a graph drawn across. If graph drawn across force taken on y-axis and time taken on x-axis, then area under force and time gives impulse. So how it is? Just take a y-axis. Along y-axis, we can take force. So this is y-axis, force. This is x-axis. So time interval. Now, according to the definition, if large force acts on a body for short intervals of time, so it is t is equal to 0, this one. So maybe force is large for the small interval of time. So look at the y coordinate. So y coordinate is large for the short intervals of time. Suppose if you go on increase the time, the application of force slowly decreases. So look at the y coordinate gap. So time is more, so time is maybe same, but reduced is force is reduced slowly. Force is reduced finally. So you'll get the graph like this. So again, time interval will be less. The change in y coordinate will be more. So this indicates that large force acts on a body for short intervals of time. So once again, so you have to mark the coordinates first, and thereafter you have to join them. So that is the way to draw the diagram. So this may be the changes found. So you are noticing the force as and when time is increased. So indicates that impulsive force. Next, so there are some daily life applications for impulse. So first one is when person jumps onto rough surface and smooth surface. So when he jumps on rough surface, he will get more injuries because the time of action of force is less. So therefore, force application of force will be more. Application of force will be more because time of action is less. So this is one example. So the person who is jumping onto rough surface there is a possibility for him to get more injuries. Second application is while catching the ball, cricketer stretches his hands back. What for means to increase the time of action so that force by the ball and the hands get reduced. So this is also one of the application of impulse. Even so, sometimes we find that the newly purchased electronic items like TVs, refrigerators are covered with thermocols. So during the transportation, maybe they receive impulsive forces. So putting the thermocols and any soft material means, so they increase the time of action so that force by the jerks while the goods are transported, force will be reduced. Even we see that fruits and medicine or vegetables are transported in the plastic boxes or let us say carton boxes. So to avoid damage during the transportation by the impulsive forces. So they increase the time of action so that force will be reduced. So finally, even inside the helmet, the thermocol is fixed. So why? Because during the accident, so the thermocols increase the time of action. So time increases the force by the vehicle with which the other vehicle is crashed. So therefore decreases. So somehow we can reduce the occurrence of the injuries. In my next video, I'll continue with the numericals based on impulse. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.